We're going to look at complex numbers. If you want to know a little bit about the history and some other things about complex numbers and where they come from, this is a great video I found on a YouTube channel called Veritasium. The video is called Epic Math Duel. I highly recommend it. I'll link it so that you can see it because it's very nicely done. So, the complex numbers. They're made up of two pieces. One, we graph along the real axis. Those are the real numbers in the normal way that we think of the real numbers. Along the perpendicular axis, the imaginary axis, or what we call the imaginary numbers, which are square roots of negative numbers. Now, a negative number is made up of two pieces, right? -1 times a positive number. Well, you could take the square root of the positive part and just get, square root of 4 is 2, stuff like that. But square root of -1, we're going to rename that as I. And these are called the imaginary numbers. Now, putting them together, the real part and the imaginary part, you get what we call the complex numbers. These are solutions to certain equations, like x squared plus 1 equals 0, stuff like that. Now, the interesting thing is when you square a square root, you get back what you started with, right? So what you'll notice here is that if I have I to the 0, I get, number to the 0 power is 1. I to the 1, that's just I, the same number. Now, when we square it, we get -1. So one way to think of it is you square a square root and you get what's underneath it. Now, what's really happening, and it's kind of cool, is when you take 1 and you multiply it by I, you do a 90-degree rotation to I. And then we take I and multiply it by I, you get -1, which is a 90-degree rotation. So then when you multiply -1 times I, you get -I, which is here. Now when you multiply -I times I, you get back to 1. So you're just doing this rotation around the circle. So what that leads to is that then we can find I to any power by just dividing by 4. Because when we divide by 4, that's just the rotations that we're getting rid of, which brings it always back to 1. So if I have something like I to the 47, I divide that by 4. It goes in 11 times with a remainder of 3. So there's 7 or 11 rotations that come back to 1, and then 3 more, which would be I to the 3rd, which is -I. And so that's how we can calculate every value of I to a power. Now we're going to use that when we multiply and divide and stuff. So let's see how we're going to do that. Because really that's all we're going to do is really just kind of multiply and add, subtract, multiply, and divide. All right. Let's do one problem here, 51. I to the 7th, 1 plus I squared. Now, really we could do this two ways. I could convert the first part, or then I could convert the second part. Let's, multiply it through and then convert, or I can convert now and then multiply it through. But I think this would be easier to do it first, because, and let's not even do both of them. Let's just do this one. This is 1 plus -1. So it's I to the 7th times 0, which is just 0, like that. So how do you add these numbers? The first thing you do is you notice that you add the real parts. A plus C gives you A plus C. That's the real part. Now you take the imaginary part, just like a polynomial. It's kind of like adding like terms. A plus or B plus DI gives you the imaginary part. Same with subtraction. You're going to go A minus C, and you get the real part, and then you go B minus D, and that's going to give you the imaginary part, like that. So it's just like adding polynomials. You kind of like adding like terms. All right, so now let's do number 18. Just addition. So again, really, the parentheses aren't really that important here because this is positive, but really it's just combine the real part and the imaginary part, so you get 1 plus 2i. That one's not so hard. All right, number 21. subtraction. Now this time the parentheses is important because really you have to distribute through the whole thing. So, but we can just think of it as 4 minus negative 6 plus 4 minus 9. So this would give you, well, that's plus 6, right? So this is 2, and that's negative 5i. All right, let's try adding. This is just a subtraction problem again. This is number 38. So let's just convert this. This is really negative 2i, because square root of 4 is 2, negative 1 is I, minus 4 times, and then this is square root of 25 is 5, square root of negative I of 1 is I, so this is negative 2i minus 20i gives you negative 22i. All right, multiplying. Multiplying it should be fairly familiar too, because it's very similar to multiplying binomials. So we can do the FOIL thing. I know FOIL is just a mnemonic to remember the just all the permutations of the distributive property, but it's a quick way to do things. So right, a times c gives you ac, right? First, a times d gives you ADI, or a times DI. BI times C, of course, gives you the BCI, and then BI times DI gives you BDI squared. Now, I squared is just negative 1, and so that's where this I squared, where we get this negative right here, because AC is a real number, BD times negative 1 is a real number, so that's the real part right there. And then you just take the other two and factor out the I, and that gives you your imaginary part. So it's just a FOIL thing. Now, to do division, we have to have something called the complex conjugate. The complex conjugate is just negating the imaginary part. So if I went back to the axis, right, I'll just draw it here to the side, right? If I have a plus bi up here, right? That's supposed to be an a. All it is a reflection around the x-axis, so this is the same distance. So the a, right, is on the vertical like this, and then this is a minus bi, right? So that's what a conjugate is, just the opposite side of the real axis. Now, something really interesting that happens with that is that when you multiply a number times its conjugate, this is the difference of perfect squares. So I get the first term squared minus the second term squared. And of course, the second term squared, we get b squared, and I squared is just negative 1. So negative and a negative becomes a positive. So this is just a squared and b squared, which is a real number. Now, that's what we're really going to want to do when we divide, is we want to turn the denominator into a real number and just put that denominator under each piece. So how do we do that? We're going to multiply top and bottom, numerator and denominator, by the conjugate of our denominator. And when we do that, we get this real number here, c squared plus d squared, which is what we just did here. And then you multiply this whole thing out just like we did up above. And then you take this real number here and you put it under the real part and the imaginary part, and that gives you your solution for the division. All right, let's try this multiplication problem. This is 27. So again, right, you just have to do the FOIL. That's 2. Negative 1 times negative 2. This is negative 3i. That's negative 4i, and then if we multiply those two, that would be 6i squared. And so that's a negative 1, so this is really 2 minus 6, and then plus negative 3 minus 4i, so this would be negative 4 minus 7i. All right, let's try 36. This is division. So what do? I multiply top and bottom by the conjugate of the bottom, which is just change that sign. But now remember to put parentheses on here, because otherwise without that what you're doing is you're saying you're multiplying this times that, but really it's the whole thing. Alright, so the denominator is the square of the first one plus the square of the b, which is 9, right? And then in the numerator we have to FOIL, but since it's the same number, again, we can use the a squared plus 2ab plus b squared equals, this is a plus b squared, like this. So we can multiply this and get that. So we're going to get 4 plus 2 times 3, 2 times 2 times 3, which is 12i plus 9i squared. So that will give me 4 minus 9 plus 12i all over 13. So those two, that's negative 5 over 13 plus 12 over 13i. Alright, here's a couple other things. This isn't necessarily in the book, but I thought it's kind of interesting. Notice that when we talk about absolute value in real numbers, we're talking about the distance a number is from 0. Well, the modulus is sort of the absolute value version of that, or the modulus is the complex version of absolute value. So it is the distance from 0. So if I take a plus bi, I'd go over a and up b. Now notice what I get is this right triangle here, which allows me to use the Pythagorean theorem. So if I take a squared plus b squared, this is this side squared. Take the square root of it, and I literally get the distance, stuff that we've learned from 2 dimensions, to get the length. Now, what's really interesting is if you go back to the previous one, a squared plus b squared is a number times its conjugate. So if this is a plus bi times its conjugate, that was a squared plus b squared, like that. So this is a squared plus b squared. Now when you take the square root of that, you get the modulus. So a number times its conjugate, take the square root, you have the distance from the origin. Now, one thing, this is strictly, these are 2 functions that are from complex. And so these are real functions. But we have to use them in our tests on Brightspace, because Brightspace is not very sophisticated program, mathematically speaking, and so I can only ask one question at a time. So I might ask you to add 2 complex numbers, and then the answer would have to be, then I'd ask for the real part or the imaginary part. Well, the real part is just a, so the real part of a plus bi, that's just the a, and the imaginary part is just the b, not the I, just b. So if I say add 2 numbers and give me the imaginary part, you add the 2 complex numbers and then just write down the real number that sits in front of the I. Alright, let's try this problem here. This is number 7. We want to evaluate f of x squared plus 3x plus 5 at f of x plus, so we're going to evaluate x plus 2i. So what does that mean? You just plug it in, right? Because that's what we do with any function. 2 plus I squared plus 3 times 2 plus I plus 5. So we have to multiply this one out, right? So this is 2 plus I times 2 plus I plus 3, 2 plus I plus 5. Now, we could just do the FOIL thing, but we do know from the past that a plus b squared is equal to a squared plus b, 2ab plus b squared, like this. So what that means is that then I can just take this as 4 plus 2 times 2i, so that'd be 4i plus I squared, plus distribute 6 plus 3i plus 5. Now that's a negative 1, so I'm going to get 4 plus I minus 1 plus 6 plus 3i plus 5. Now we just combine, the real parts. So we get 5 and 6 is 11, minus 1 is 10, plus 4 is 14. And then we just combine the real parts and we get 7i, like that.